Sketching curves in this question. We're given a function, and the first thing we're asked, well, we're told that we got some asymptotes, y equals 0, x equals 0, and x equals b. And we're also told that it crosses the x-axis at a0. So how do we get a and how do we get b? Well, I think I'll look at b to start with. B is going to be from looking at the denominator. It's where the curve basically it can't exist, and it's going to be when the denominator is 0. And one option is when x is 0, which we've already dealt with. So the other option is going to be when x is equal to 3. And that's going to mean that b is equal to 3. At that point here, we're going to, the function is not defined. For a, we need to think about what happens, like what value of x is going to make the function 0. And it's not going to affect the top, it's just going to be the bottom. So it's got to be that 4a minus 1 is equal to 0. It's going to be what makes this 0. And from that, we can see that a is just going to equal 1. I don't need to multiply this out or anything. That's going to be what we get. So 4 and x equals 3. In the next part, we're asked to transform this original function. But we have to show any coordinates of intersections and state the equations of the asymptotes. Now, it might help to actually write the function down, but we can do a lot before we write it down. So I think what we can see is that we're going to have a translation by minus 2 minus 4. Because we're minusing 4 from the function, we've got a plus 2 in here, so we do the opposite, and we get a minus 2. And therefore, the asymptotes will become, and you can do this without writing the new function down. We had x equals 0 and x equals 3. We're just minusing 2 from them. So it's going to be x equals minus 2 and x equals 1. That's going to be useful. And there's another one, because remember we had y equals 0 as an asymptote. So we're now going to need to subtract 4 from that, and that will give us y is equal to minus 4. So I've dealt with all the asymptotes. The only question left, actually, so you can sort of see this moving to the left and moving down. The main question is we're asked about any intersections with the coordinate axis. So, because A is going to move somewhere else, like it's not going to be on the coordinate axis anymore. Therefore, I think it's worth writing it down. X plus 2 minus 4. This is going to become 4 lots of, now I just replace x by x plus 2, so it's going to be an x plus 1 here. And then it's going to be x plus 2, x minus 1, and we're minusing 4 from it. Now, when x equals 0, this is going to be 4 divided by minus 2. All I'm doing is replacing all of these by 0. So 4 times 1, and then I'm going to be divided by minus 2, because it's 2 times minus 1. And then I'm going to be minusing 4. That's going to be minus 6. So we've got a point of intersection. And then when y is equal to 0, maybe I should call this thing y just to make it really clear. Y is equal to this. When y is equal to 0, we're going to get that 4x plus 1 over x plus 2, x minus 1 minus 4 is equal to 0. And what I can do is I can add 4 to both sides and divide through by 4. It must be that x plus 1 over x plus 2, x minus 1 is equal to 1. So x plus 1 will equal this thing, which I can multiply out to give me x squared plus x minus 2, which means x squared is going to equal 3, and x is going to be plus or minus root 3. So I've got this asymptote, this asymptote, this asymptote. I've got when x is 0, I get minus 6, so I get 0 minus 6. And then I also get minus root 3, 0, and root 3, 0. These are going to be my crucial points that I now can draw. Okay, so I'm not going to scroll up the screen and show you each one, but we had x equals 1, and we had x equals minus 2. So I just put it roughly in the right place, like in terms of scale. And then we don't have to have the same scale along the x and the y-axis, so I'm just going to put this as y equals minus 4. And if you look at the asymptotes before, you can see that where the asymptote is here, you just get this kind of 1 over x style curve, and you get it over here. So I would add those first. And then here. And this point's got to be the root 3, where y was equal to 0. So we've added that on. Now all that's left is the other part. So if we look at the function and we think about the translation, well, it's still going to look a little bit like this. It's like a kind of like a negative cubic. It's not, is it? But it's a little bit like that. So I can just draw it in. I just got to be careful. Remember, it went through at minus 6, so it needs to be below the asymptote. Something a bit like that. So we're going to get minus root 3 here and minus 6 here. And that is a pretty decent sketch, I think. I'm just going to add x here and y here. We now have a second function to sketch. Okay, we've got a modulus involved. So don't forget, if x is greater or equal to 0, then this is simply this function here, f of x minus 3. And if it's less than 0, then we make it f of minus x minus 3. And what this actually means is that it's a reflection of the right-hand side, like the right-hand graph in the y-axis. So we only really need to focus on x is greater or equal to 0. Now, there's different ways of approaching it. What I'm a little bit tempted to do is think about y equals f of the modulus of x to start with. And then we can just think about how it's affected. So we've got this here. Because then we'll just have a transformation of this function. So this, like basically the function will look exactly like this on the right hand side, and then it will just be a mirror on the left hand side. X equals minus 3. This will be minus 4. And I'll get that curve there. So we just need to think about how everything will be affected. Um, and the asymptotes will remain as x equals 3 and x equals minus 3. But we'll also get y is equal to minus 3 because the y equals 0, 1 will be translated. Sorry, so I'm now talking about y is equal to f of the modulus of x minus 3. Apologies, I didn't make that clear. This is going to be a translation by okay, sorry, I feel like I feel like I'm still linking too much to that first graph. So we're moving away from that first graph. And it's going to be a translation by 0 minus 3. We've got our asymptotes. Now we just need to find out what's going to happen when I move the curve down by 3. Essentially, we're going to expect it to get two roots. There's going to be a root along here and along here. And actually, we can see that we don't have an x equals 0. So no y-intercept. But when solve of x minus 3 equals 0. I'm just going to look at the right hand side, and from that we can get the left hand side. Therefore, it's going to be 4x minus 1 over x minus 3. That's our f of x. That's going to equal 3. And therefore, 4x minus 4 is going to equal 3x x minus 3, or 3x squared minus 9x. We've got a quadratic, we're expecting two solutions, like I explained why, because this is going to come down and this is going to, we're still going to get one over here. 3x squared minus 13x plus 4 equals 0. And I'm going to expect this to factorize. It could not, but let's give it a go. Well, minus 13 is quite a big number compared to 4, so I'm going to have to try and max out 4 over here, I think. And that would give me 12x and x. So that's going to work if I make this minus and this minus. X equals 1/3 or 4. And we're basically done. So we can sketch this now. I still have my asymptotes at x equals 3. And remember, it's going to be a reflection on the y-axis, so it's also x equals minus 3. The y equals 0 asymptote is translated in the negative y direction by 3, so it's y equals minus 3 here. And then it will have the same kind of shape, like that. And that must be 4. This must be 1/3. We then have a reflection -4 and at -3rd. And that's our sketch. Well done.